Uh, so in this video, we will learn about the Nyquist plot. The foundation of Nyquist plot are the foundation of the Nyquist plot is the polar plot. So we start with polar plot because that is the foundation, and your Nyquist plot is an extension of the polar plot, or you can say it is an example of polar plot. So first, coming to the different types of graphical visualization we've seen in the previous lectures. We've seen Bode plot where we have plotted magnitude in dB versus the frequency, and we've again coming to the Bode plot. The second part was phase angle versus the frequency. So using these two, we could find out the gain margin, phase margin, which would tell us about the relative stability of the system. Similarly, we have seen root locus where the locus of the roots of the characteristic equation was plotted where the k, that is gain of the system, was varied from 0 to infinity. Again, using the root locus, we could find out the relative stability of the system. Similar to those visualization, we have another type of visualization which is called as polar plot. Now polar plot is the yeah polar plot are the plot of g of j omega, that is sinusoidal transfer function, in the complex plane. In the complex, sometimes we call it as the S plane. So how it is like? It is plot of real part of g of j omega versus imaginary part of g of j omega. So the plot between real versus imaginary part of g of j omega is nothing but polar plot. Now, how do we plot this? The plot is when omega is varied from 0 to infinity. We've seen in root locus that we vary the gain from 0 to infinity. Whereas in case of polar plot, we are varying the omega, that is frequency, from 0 to infinity. So the plot is something like this. So this is your complex plane, or we call it as the G of S plane. This is real part and this is imaginary part. This is 0. So this is polar plot. Now one by one we will draw the polar plot for different functions. So that way we will understand how to draw the polar plot. So first I will take a function g of s is equal to 1 by s. So this is the first factor that we will consider, and we will see how to draw the polar plot for this function. So the first step here is that step 1 is what is the sinusoidal transfer function? Simple, that is g of j omega is equal to 1 divided by j omega. Now I need to write this in a complex form such that I will separate the real and imaginary part. So this I can write it as minus j by omega, or 0 plus j of minus 1 by omega. So this is the representation I have used. This is in the rectangular form. Coming to the polar form, it is the magnitude of this is 1 by omega and the angle is equal to minus 90 degree. So this is the representation of the g of j omega in terms of polar form. Now as I've told you, we vary the omega from 0 to infinity. So we'll do it in a similar way. Now I will first take when omega tends to 0. So omega is tending to 0. So when omega tends to 0, what happens to the, so I'll just make a table. So this is real part of g of j omega, imaginary part of g of j omega, then magnitude of j omega, then angle of j omega. So if we follow this particular format in every step, in every type of polar plot, it is much easier to visualize the actual position or actual quadrant where the Nyquist plot or the polar plot will lie. That is the reason why I'm using this particular approach of tabulating it. Okay, so now first one is when omega tends to 0. So remember that here omega is not exactly equal to 0, it is just tending to 0. Like we apply limit, it is tends to 0. So real part is 0, no matter what, it will remain 0. Now coming to the imaginary part, if omega tends to 0, 1 by minus 1 by 0 is your, sorry, minus 1 by omega is your imaginary part. So you apply omega tends to 0 here. So this will tend to minus infinity. I'll just give this arrow direction, which means that it is tending to minus infinity. And when you take the magnitude of this will be infinity. So just put here omega tends to 0. So this is infinity. And your angle will be, no matter what, it is minus 90 degree, because your angle is not dependent on the frequency, that is omega value. It will remain minus 90 degree. This is the first thing. Second thing, I'll take when omega tends to infinity. So when omega tends to infinity, again the real part is 0. Now here the imaginary part will be, when you take here it is 0. Sorry, this is infinity. So this is 1 by infinity is 0. I'll simply write it as minus 0. Okay, I'll keep the minus as it is. Though minus 0 and plus 0 makes no difference, but I'll just keep minus sign as it is so that we will understand the about the quadrant. Okay, just to understand about the quadrant, I've kept it as minus infinity. In real situation, minus 0 plus 0 makes no sense. It is only 0. That's it. Okay, and coming to the magnitude of it, it is 0 and angle is minus 90 degree. So this is how we have tabulated. Okay, so I have tabulated the magnitude, the real part, the imaginary part, and the angle as omega tends to 0 and omega tends to infinity. So now I'll try to plot this. So yeah, this is the G of S plane. This is real part and this is imaginary part. This is 0. Okay, I'll just use a lighter color so that when I plot the plot, it will be visible. So real, imaginary, 0. This is the G of S plane. Okay, so this is my G of S plane. Now here I need to plot these two curves. Okay, so now you can see that when you vary your omega from 0 to infinity, we vary the omega from 0 to infinity, the imaginary part will always be negative. We can say it is minus 1 by omega. So omega cannot be negative value. The frequency cannot be negative value. So omega will always be a positive value. So if I say, if I vary the omega from 1 to around 1000, my imaginary part will always remain negative. That is the first observation we have to make. So the first observation is that as we vary omega from 0 to infinity, okay, the imaginary part of g of j omega will always be negative, will always be negative. That is the first observation we have to make. So this imaginary part, that is this column, no matter what value I take 0 0.1, 0 0.2, 0 0.3, then I take 50 hertz, 100 hertz, 1 kilohertz, 1000 kilohertz, 10,000 kilohertz, no matter what high value I take of omega, my imaginary part will always remain negative. That is the first observation. Second observation is that the real part will always remain 0. That is, your real part is not varying with respect to omega. So the second observation is the real part of g of j omega will always be constant at 0. So your real part is 0. It means that the plot, when you plot the g of s on the s plane, real part is 0. It means that your root locus will, sorry, not the root locus, the polar plot will lie only on the imaginary axis. Your real part is 0. It means that the polar plot will lie only on the imaginary axis. Now you have two parts of imaginary axis, this, the upper part and the lower part. Now I have told you the imagination part of g of j omega will always be negative, which means that you cannot have the upper part here. You cannot have anything, any points on this part. So whatever will be, it will be on this part only. So your polar plot will look something like this. So you should, this I'll take it as minus j infinity. This point I'll take it as plus j infinity. Okay, so this is the point. So this point I'll take it as, theoretically infinity is some large value. We cannot plot it sometimes, but this extreme end of the imaginary axis, I'll take it as minus j infinity here, plus j infinity here. So at omega equal to 0, it is infinity at an angle minus 90 degree. So when you take minus 90 degree, this is minus 90 degrees and this is plus 90 degree. As I've told you, when you go for clockwise direction, it is minus 90 degree. When you go in anti-clockwise direction, it is plus 90 degree. So this is already discussed. So the degree thing, I don't think I have to explain it again. So this is plus 90 degree, this is minus 90 degree. This is plus 270 degree and this is minus 270 degree. This is plus 180 and also minus 180 degree. This is 0 degree or 360 degree. Okay, this is how we write the angles. So now it is infinity at an angle minus 90 degree or 0 and minus infinity point. This one, the omega is equal to 0. It is, the point is 0 minus infinity. So this is your 0 minus infinity point. 0 minus infinity point. Similarly, at omega tends to infinity, it is 0 minus 0 or 0 and 0. So this is 0 comma 0 point. So this is your 0 comma 0 point. Now you are moving from, so this point is for omega tends to 0. This point is when omega tends to infinity. So we are moving from omega tends to 0 to infinity. So it is a straight line. So why it is a straight line? Nowhere you will have a real part. It has to be a straight line. So and the direction is from down, bottom to upper point. So this is your polar plot for 1 by s function. Okay, so next we will have the next factor in the next video. Thank you so much.